In this part of the lectures, we will cover the security aspects of handovers. And there are two parts in here. The one is key derivation and the other one is PDCP count handling. If you remember, when we had looked at key derivation and the key hierarchy, we had gone through this key hierarchy and said that we got the KSME key from where we derived the key eNodeB that was provided to the eNodeB, and the mobile had derived that also. And the key eNodeB was used for encryption and integrity protection of the SRBs and also for the encryption of the data radio bearer. We had also said that from the KSME key was something which is derived was something which is called the next hop key, the NH key, which is derived at both the UE and the MME, and it is used to change the keys, the K eNodeB, when the mobile moves from one eNodeB to the other. So we will look into the details of how this new key is derived and how to, and the main idea of the key is that the source eNodeB should not be able to know the communication or should not be able to decipher the communication that's happening in the target eNodeB. So in some way, if a source eNodeB is compromised, we still the communication still with the target is not decodable by the source eNodeB. That's the goal for key changes whenever the UE moves. The other part about PDCP count, we had kind of looked at the when we had looked at the access stratum, we had said that for the encryption and the integrity protection, there was the count value, or the PDCP count value, which was being used, which was a 32-bit number, and which is a concatenation of the sequence number in the PDCP. So we will look at how this count value changes when we do have handovers, and is it carried over or is it not carried over, because that would impact how the encryption and the integrity protection both in the mobile and the network would be done. So with this as the motivation of what we are going to cover in these parts of the lectures, let's get started to take a look at the key derivation. So for the key derivation, we will look at a simple example of a network where we'll first consider intra-eNodeB handovers and X2 handovers. And for this, to study this, we have this example network where we have an MME with 3 base stations, and there is an X2 interface between all these base stations. So in this part of the lecture, we'll first consider where we have X2 interfaces, and in the next part we will also look at what if this X2 is not there, and instead of the X2 interface we have got to do an S1 handover. And we will focus on the security aspects and the key derivation aspects per se. Now, each of these base stations, as I had previously said during the key derivations, in most of these base stations end up being 3-sector base stations. I mean, so they have antennas facing in 3 different directions, and each of these directions, each of these parts are called sectors. And the way we are going to name these sectors, so this is going to be 0, 0 sector, this is 0, 1, and this is 0, 2. This would be 1, 0, 1, 1, and 1, 2, and so on and so forth. So we have, these are the 3 sectors that we have for in our example network over here, right? And we will look at how the keys are derived as the mobile moves in this network, and the mobility we are going to consider is when the mobile moves from sector 0, 0 to 0, 1, and then it moves to 1, 0, 1, 1, and 2, 0, and then 2, 1. So this is the trajectory, and at each of these steps we will see what the keys, what is the key used for the access stratum. Okay, so we start off from the KASME key, which is the key at the MME, and also that the mobile has this KASME key, which is kind of the foundation for the key that is used for the access stratum, or the K eNodeB. So during the authentication procedure, after the authentication procedure, when the context is being set up, we had seen that from the KSME key, we derived the KENB0 key, which is the key which is going to be sent down to the very first eNodeB where the mobile has attached. And the key derivation function is actually just a secure hash algorithm with 256 bits, which takes the key, which is KSME, and then takes a sequence which for all practice, the main part of it is the uplink NAS count. Now there are other things also involved in here, but from a conceptual point of view, the main parameter is the uplink NAS count, which is what the MME has, and the UE also knows after the security mode command has been successfully completed. So they both have the same count, and they use the same uplink NAS count and the KSME, and they come up with KENB both at the UE and in the network. And the network goes ahead. So we will also represent this derivation with this SHA-256 on the right hand side by showing this kind of a notation where you have the uplink NAS count and the KSME coming in, and out comes the KENB0. So this is the equivalent representation, short form representation of the key derivation function that is going on, right? So the key KENB is derived, and also the MME also derives what's called the next hop, and the next hop parameter, which it stores for itself, and it is not used in the network. We'll see that it is further derivations are used, but it is not provided to the eNodeB during the UE initial context setup. And this next hop 1 is derived based on KENB0. So first KENB0 is derived, and then using KENB0 and KSME using the same key derivation function, the SHA-256, you get next hop 1, and this is stored in the so this is derived in the MME, and actually the UE can also derive it right at the starting, but there's an option that the UE can derive it a little bit later also, and we will look at that. So then after the KENB is derived and the NH is derived, the MME provides the KENB to the eNodeB0 as part of the UE initial context, and this KENB0 is used for encryption and integrity protection in this sector 00. Now, once this KENB comes down to the eNodeB, it sets automatically on its own the NCC, or what's called the next hop chain counter, to be 0. So this is a convention. The mobile also sets the next hop chain counter to be 0, and this is at the very starting, at the initial context setup, that this is happening. And in the figure we also show that this NCC is set to 0, and we'll see the importance of NCC in a bit when we look at some of these derivations that are going on, right? And so this KENB is and also this NCC is also set to 1 for this NH1, and that's the convention which is being used, just so that you know what the convention in 33401 is. So NCC 0 is for the KENB0, and NCC is set to be 1 for the next hop counter for 1. So this KENB0 is used for encryption and integrity protection in the access stratum for the sector 00. So this is what is being used in sector 00. Now, when the mobile needs to be handed over to the next sector, which is 01 of this eNodeB0, the mobile, the base station goes ahead and gives the UE handover command. And in the handover command, the next hop, the NCC, is set to be 0. So the mobile knows that the NCC is not changing. It previously had a NCC 0. The NCC is set to be 0 in the handover command. With the handover command, E node B also tells the mobile the sector to which it needs to move to, other parameters that it needs, and with those parameters the mobile moves over into this sector 01. Now the key derivation which is having the same NCC 0 for the next sector is done based on K node B0. It takes in the target physical cell identity and a mouthful for what is the downlink frequency index, which is also this EAR, FCN downlink. So this is the frequency used in the downlink in that particular sector is given an index, and that is what is used in the key derivation function, which uses the KE node B0 to come up with KE node B01. So this KE node B01, which is derived in the mobile and derived in the network, are used for encryption and integrity protection at the access stratum in this sector 01. Right, and this is what's called a horizontal key derivation, is because you have derived the next key based on the KE node B0 and in the figure it kind of goes horizontally, and we will look at what a vertical key derivation would be. So this is called a horizontal key derivation in 33401. One thing you know that since it is in the same base station, the keys are changing, but if you do know KE node B0, you can derive to KE node B1 easily, right, in the horizontal key derivation. And then while the mobile is in sector 01, the mobile needs to then kind of get moved to sector 10 to the next base station, and based on radio measurements, the E node B0 goes ahead and provides sends a handover request command to E node B2 using the X2 interface, where it computes the key that should be used in sector 10 based on another horizontal derivation, where the key E node B01 and the physical cell identity and the downlink frequency index of the target is taken into account, and KE node B01 is kind of computed. So this is another horizontal key derivation that is happening. So even though you have gone from one E node B to the other E node B, the key that is going to be used in this sector is actually derived by the source E node B. So the source E node B in an X2 handover at least knows the key, is able to know the key of the very first sector where the mobile gets handed into. And we'll talk about how to work around the situation, that if you want to break the link that the source E node B shouldn't know the key that is being used in the next cell, what should be done. But at the moment, let's just take this case. The mobile kind of has moved, is being handed over to E node B1, sector 0, and then the E node B sends a handover command to the mobile, and in that handover command the NCC is set to 0. So with the NCC set to 0, the UE also knows that it needs to do a horizontal key derivation. So the KE node B, the key is never sent over the air. So the only thing that is sent over the air is the next hop chaining counter, the NCC value, and based on the NCC value, the mobile knows whether it needs to do a horizontal key derivation or it needs to do a vertical key derivation, which we'll come to in a minute. So based on this NCC is equal to 1, the mobile goes ahead, moves into, with this handover command, it also is given some parameters of the target cell. It goes over and it derives KE node B10 by doing horizontal key derivation based on the target PCI and downlink frequency index. And during the handover procedure, after the handover happens, the X2 handover, during the X2 handover procedure, first the communication happens over X2 interface, and then this target E node B asks for a path switch request to the MME to change the path from the source E node B to the target E node B with the serving gateway, which we aren't showing in this figure. And when the path switch request comes in, the MME derives a new next hop key, NH2, based on the NH1 that it already has, and based on KSME using the same key derivation function, and it would provide this next hop 2 counter to the mobile in the path switch response. It provides next hop 2 with NCC value set to 2. So this is what so typically the next hop and NCC are in a pair. So the next hop and NCC is sent to this eNode B during the path switch request, but by the time it has come, the key has already been derived and is being used in this sector 10. So this next hop 2 and NCC is not used for the keys used in sector 01. Now, once the eNode B has NH and NCC, and it needs to do the next handover to the sector 11, it goes ahead and sends a handover command to the mobile, and it tells the mobile that now I have a fresh next hop, since the eNode B has this fresh next hop counter and next hop parameter and NCC. It says I am going to use NCC equal to 2. So based on that, when the mobile moves into the target sector 11, it does a key derivation. So it itself, kind of based on, it had KEnode B0 over here, it had been provided that. It has KSME, so it goes through and computes NH1 and it computes NH2, and hence since NCC was set to 2 and NCC 2 means it has to use NH2. So it, based on NH2 and the target cell identity and physical cell identity and frequency index, computes this KEnode B1. So this is what is called a vertical derivation, because the derivation of the key is that the derivation of this key is based on the NH2, which has been derived vertically from NH1. Okay, and so up to this point we had the horizontal, and at this point from KEnode B 10 to 11 we have a vertical derivation. And now we will take a look at what happens at the next handover, which is going from this sector 11 to 20, which would be very similar to this one. So the base station eNode B1 goes ahead and computes KEnode B20, doing a horizontal derivation, because it has already used NH and NCC in order to get to KEnode B11. Once NH and NH has been used, it cannot be used again for another key derivation, and hence that is the rule in the base station, is if you have a fresh NH which you haven't used for a key, you use it for doing a vertical key derivation, and once the NH has been consumed, then you do a horizontal key derivation. So the horizontal key derivation gets done for 20, and the mobile kind of also does a similar one, because once the handover command comes, with NCC equal to 2, which is the same NCC that it had when it had done KEnode B11 derivation. So the mobile also does a horizontal key derivation, and when it shows up over here, it has KEnode B20, and and then the path switch request will happen, and in the path switch request the MME will send down NH3, and once it sends out NH3, this would be used in the next handover from this 20 sector to 21, where NCC3 will be sent, and we have a vertical handover, and KEnode B21 is kind of derived. And so based on this figure, one of the things that you can see is that the first movement into a new eNode B, the first sector of the new eNode B, is still a horizontal key derivation, but the next one is within the eNode B is a vertical key derivation using the next hop key, that the next hop parameter that comes from the MME. And with this KEnode B11, since the old eNode B doesn't know the NH value over here, it doesn't know the KEnode B11 key, so it cannot snoop into whatever is happening over here. So the chain is broken once you get a vertical key derivation done. And then the same over here, when you move from this sector to this, you have a vertical key derivation. That means the KEnode the eNode B1 cannot snoop into the traffic that is being kind of transmitted on this side. So one of the rules in, if you really want to be very secure, the way the spec says is that it is an option for the mobile, for the eNode B, that after the very first handover into the sector comes in, after it gets a path switch request and the next hop 2, it can go ahead and do an intra-cell handover. So basically not even move the guy into the next cell, keep him in the cell, do a handover command, give him that the NCC is set equal to 2 and then derive a new key which will be used by vertical key derivation in this sector itself. So intra-cell handover is also a possibility just for changing the key from KEnode B10 into a vertical key derivation that gets used using NH2.